What's going on? I found a cool project on Hackaday and I wanted to share it. They're called TritiLED and it's made by Ted Yapo. A lot of cool engineering has got into this, but really it's just an LED that runs off a coin cell battery. But it can last for years without a battery change, up to 20 whole years in some cases. And that's 20 years of lighting an LED off a small watch battery, which is just insane. I saw this and I thought it was super interesting, just the sheer dedication to efficiency. And I was also looking for a fun project, so I decided to build some of them. Now, the first step is knowing that I want to build some, and then the second step is to make up a problem in my life that I can solve with them, so I can justify the $100 it'll take to build about 10 of them. I have an idea of this problem, and we'll get into it a little later, but the short version is I want to line my driveway with these LED markers so it can be seen better at night, plus it's just going to look cool. Building these could also be a fun intermediate level project to get your soldering up to just that next level and build a whole project front to back. Let's start by picking which version we want to build. We really just have a choice between version 2.2 and version 3.0. Version 3.0 has a bit more features and modes, and this one is the one that can go up to 20 years or so. And version 2.2 uses some different parts, a different LED, but really the main difference between the two is that version 2.2 can only go to 5 years, whereas 3.0 can go even further. It's got a few modes, with the max one being 20 years. So after looking through these, I decided on version 2.2. Why? Because some of the links to the parts for version 3.0 didn't work, and I'm not about to do any of my own thinking. Plus, 5 years is plenty for what I'm trying to do. There's no way I could find a 100 picofarad capacitor that'll fit on my own. Okay, yeah, you got me. I saw one broken link and my mom got scared and she said, "You're moving to version 2.2. But, spoiler alert, I already have the parts, so I can't change what I did now. So throw those bad boys in the cart and hit purchase. Parts are here. We've got the PCBs from Osh Park and the rest of the parts. Battery clips, the LEDs, MOSFETs, resistors, capacitors, inductors, some stuff in between, and the microcontroller to run it all. Alright, let's solder this thing together. From the project, I'm going to be following this parts guide here. It really just tells you where to put things, makes it super easy. And then once we have it all soldered together, we need to program the PIC12 microcontroller. So we'll go over that as well. Let's get started soldering this all together. So the first thing that I'm going to do here is pull my balls out. Next, we're going to get all our components out on the table, ready to go. And then we're going to start putting them on this board. And to put them on this board, we're going to use solder paste and then a hot air rework station. You don't need these to pull this off. You can do this with hand soldering, and it would be some good practice. But there are some small components, and not only that, doing this method allows us to make many of them a lot faster. This solder paste has also expired in 2018, but it should still work fine. And by work fine, I mean it at least gets the job done. You can see here this stuff is a little more crusty than normal. It doesn't spread the way nice solder paste does. Either way though, let's get some solder paste on all these pads so we can put the components on here. Now, because of this crusty solder, this is some particularly ugly and bad application, but if you're new to solder paste and placing components, you don't have to have perfect distinct boundaries. You really just need to make sure you don't have too much on there. If there's too much, it'll kind of turn into a river of solder and parts will float around. But as long as you've kind of got solder paste in the general area and your components are close to the pads, it should work. So what is the excuse I made to build these anyway? Well, My driveway is gravel, and it looks like this. So when it snows, even when I shovel, it looks like this. Even if I take the time, I can't really shovel out all the snow to a bare driveway. So I am kind of forced to leave a small layer of snow on my driveway. That's not much of a problem in itself, but the other half comes from my addiction to ordering food delivery. I have noticed that during the winter months, when it's dark outside, which is very often in winter, not only is it hard to see, but many delivery drivers see an unmarked snow-covered driveway and either assume they will get stuck or they legitimately have a hard time seeing where to park, even with my front lights on. So they try to pull off to the side, but I live on a thin, busy road. And in the winter, either side of the road is just a pile of snow, so this leads to them half pulling off, half blocking traffic, putting on hazards, things like that. So I'm hoping by putting these on some poles on either side of my driveway that the delivery drivers will be more likely to park in a safe spot. Could I have accomplished this with just some driveway marking poles? Yes, I could. In fact, that's exactly what we're going to be mounting these LEDs to. But this is way cooler, and plus I get to make an electronics project, so it's really a win-win. Note that after we finish soldering these components, we are going to hand solder the LED and the switch because they won't take the heat as well from the hot air rework station. The components are all placed. I'm going to put it in an alligator clip here to elevate it off the table so I'm not burning anything. Get the hot air rework station all warmed up. I'm going to set it to 250 degrees and then the airflow somewhere around half. If you have it too high, it can blow components off the board. And if it's too low, it might just take a long time and you can overheat parts. So, got to find that balance. I'm waving the heat gun around here. I don't want to heat up one spot too much, kind of going back and forth. We want to get heat soaked into the board as best we can, and then I'll kind of focus on a specific area after everything's up to a decent temperature. When you get into really specific stuff like reballing full-on BGAs, there's a little bit more of a recipe to exactly what temperature, when, what steps, how big a nozzle. But when you're doing something like this, and for a lot of just desoldering specific components, repair work, it's a little bit more of a feel than it is a specific set of instructions. As you can see, it looks like that one went nice and smooth. Just gonna clean it up here a little bit. There's actually not too much to clean. Really happy with the result for this one. Let's start soldering on the LED now. To get it in place, I'm going to start by tinning one of the pads and then kind of heating and pushing down the LED to get it stuck. So then I have an easier way to solder the joints without the LED moving all around. Slap on the button and the battery holder, and let's get some firmware on this bad boy. And we're gonna flash the microcontroller with some titty software. I mean TritiLED software. Well, after buying all the parts for this TritiLED, I did not pay enough attention to the microcontroller. And if you look real close, it's a PIC microcontroller, which are very cheap, but they require a specific programmer to flash them. I have tons of microcontroller flashing utilities. Look at all these. I do not want to buy another one. Yeah, it's only 35 bucks to get the right one, but this is a matter of principle. With all these gadgets, there has to be a way to flash a PIC without having to get a flashing utility that I might never use again. And after some searching, there is. Shout out to this guy. Right as I finished editing this video, I realized that this was a fork of a different piece of software, which in turn was another fork, and this is actually created by this guy right here, Jarmir. Anyway, I want to make sure I give the right credit, but in the video you will see me using this initial one just because that's where I got all my footage, but this is just a fork of a fork. Shout out to this guy for making some software that'll let you flash a PIC microcontroller with an Arduino Uno. This has like no stars, it deserves way more. Anyway, I have tons of Arduino, so let's go on a quick side project. First we gotta grab the pp.ino for our Arduino and open it up in Arduino IDE. Then flash it to the Arduino Uno. Next grab the pp3 devices.dat and the pp3.exe. Say hi to the kitty. Hook up the Arduino to the PIC microcontroller. I use this little in-circuit grabber and some DuPont connectors. You can find which wires go where by comparing the datasheet to the GitHub repo. Download the TritiLED 2.2 firmware. Open up a command line interface and run pp3.exe with the right flags. If everything goes well, it'll look like this. As you can see, it did not go well at first. I just had to reattach, move around the wires until it eventually did work. And here we are. We soldered it all together and flashed the firmware. Now we just gotta throw in a battery and see how it goes. Hell yeah. We know the firmware flash worked because without the firmware, this light won't turn on at all. If we press the button, we can switch its modes to have it blink slower and make the battery last longer. And finally, I 3D printed the case that's on the TritiLED GitHub. I ended up removing the button so that it would fit, and this is how it looks. I didn't put the screws in either. I just sealed it with the nectar of the engineering gods. Hot glue. Now we just gotta make 9 more of those and tape them to the top of some marking poles, and I think we'll be ready. Here's the end result. It's a little hard to see in these images and video, but it does look better in person. You can see kind of the straight lines marking the driveway, and I think it does work pretty well in person. They stand out quite a bit. You can tell that there's something here and it's not just a mound of snow, so great. Now for the most important test. Does it work? Will they pull into my driveway when they deliver the food? It worked. That's it. Thanks for watching. I hope it was interesting and made you want to go make something. I know I had a lot of fun, and I'm going to be making up more excuses for more projects down the road. Bye.